Hi everyone. In this video, we want to learn how to check for amicable pairs. Before we begin, let me first read out the question. So write a Java program to check two numbers if they are amicable numbers or not. Amicable numbers are two different numbers so related that the sum of the proper divisors, factors of the number, excluding itself, of each is equal to the other. And first 10 examples of amicable pairs have been given. So let us try to understand through the help of an example. So for the first two pairs, 220, for the first pair, 220 and 284, they form an amicable pair because the sum of the proper divisors of 220 is equal to 284. Moreover, the sum of the proper divisors of 284 is equal to 220. And because of this reason, these two numbers form an amicable pair, right? So before we begin, I would like to identify the two subtasks that are here in this problem, that are needed to solve this problem. So the first subtask is finding out the sum of the proper divisors. That's the first thing. And the second thing is to check if they are amicable numbers or not. All right. So let me jot down the subtask first. So the first subtask is to find sum of proper divisors. Proper, I'm sorry for this. It's sum of proper divisors. This is the first subtask. And the second subtask is to check for amicable pair. All right. So let us first try to solve the first subtask. All right. Okay. So how do we find the factors of a number? We know that a number has factors between 1 and itself, meaning if a number is n, for a number n, it has factors between 1 and itself, so n, right? But not all the numbers falling in this range are factors of the number. We need to check if the number divides n. If it does, then only it's a factor. So here we have three numbers, 12, 6, and 9. Now our objective here is to write the factors of these numbers. So we know for 12, the factors of 12 would lie between 1 and 12. So let's check what are the factors of 12. So 1 completely divides 12, therefore 1 is a factor of 12. 2 completely divides 12, so does 3 and so does 4. But 5 does not divide 12. But 6 completely divides 12. 7 does not divide 12. 8 does not divide 12. 9 does not divide 12 because it leaves the remainder of 3. 10 does not divide 12. So is for 11. But 12 divides 12, and hence the last factor is 12. Let's do this for 6 as well. So 1 divides 12. 2 divides 12. 3 also divides 12. But 4, I'm really sorry, not 12, 6. But 4 does not divide 6. 5 does not divide 6 because it leaves the remainder of 1. But 6 divides 6, right? Let's do the same thing for 9 again. So 1 divides 9. 2 does not divide 9 because it leaves the remainder of 1. 3 completely divides 9. 4 does not divide 9. 5 does not divide 9. 6 does not divide 9. 7 does not divide 9. So is for 8. But 9 divides 9. Now I want you to observe something here, a pattern here. What do you think the limit for the factors of a number excluding itself is? For example, in the case of 12, if we leave out the last factor, which is the number itself, we see that the last factor excluding itself is 6, which is half of 12. Moreover, in the case of 6, if we leave out the number itself, 1, 2, 3, we see that the last factor excluding itself is half of that number. Moreover, the factors of a number excluding itself lies between 1 to n by 2. For example, in the case of 9, if we exclude the number itself, we see that the last factor is less than half of the number, that's 9 by 2. Okay, this is an observation that we need to make. So, the factors of a number n, excluding itself lies between 1 and n by 2, less than or equal to n by 2, right? So this is an observation that is important for us to write the code for finding out the sum of the proper divisors. Proper divisors meaning the factors of a number excluding itself. So let's move on to the code. So we are required to find the proper divisors, the sum of the proper divisors of 220 as well as 284. So let's see how the code is going to be. So first we're going to need a variable, say sum1, in which we are going to store the sum of the proper divisors of num1. And we're going to initialize sum1 with 0. Next, as we know from our previous observation that the factors of a number excluding itself lies between 1 to n by 2, we're going to run a loop that is going to count from 1 to n by 2, and n being num1 in this case. And I is going to increment by 1. So shift this a little bit. All right. Next, what we're going to do? Next, we're going to check whether the current number is a factor of num1 or not. Or, in other words, whether I is a factor of num1 or not. So we do that by checking whether I completely divides num1, meaning it leaves no remainder or leaves a remainder of 0. So num1 mod I equals 0. If this is the case, that means I is a factor of num1 and that needs to be added to sum1 plus I. All right. And if it is not a factor, then we continue with the loop. Moreover, what do you think the code for finding the sum of proper divisors for 284 would be? You guessed that's going to be the same as this program. You're right. We're going to write the same thing here. We're going to take another variable, sum2, initialize with 0. And the code is going to be the same for finding out the proper sum of proper divisors for this, let's say this number as well. So I'm going to make this a little bit smaller so as to fit the screen. And then we're going to need to change a few variables. So the changes are going to be highlighted using pink. So we are no longer finding the sum of divisors for num1, we are finding it for num2. Let's change all 1s to 2s. And that's it. This is the code for finding out the proper divisor, sum of proper divisors for 284. But do you notice something? You see, isn't the code for finding out the sum of proper divisors for 220 and 284 the same? And this is an example of a repeated code, or in other words, a wet code. Wet is an acronym for write everything twice. We should always refrain from writing this kind of a code because this leads to redundancy. Moreover, there's no need for a repeated code because we know that that the logic for finding out the sum is same whether the number is 220 or the number is 284. So this is the point where it should click in your mind that we need the help of a function to remove or reduce the redundancy. Let's see how it's done. So for doing it, we write the same code. The names of the variables have been changed a little, but the code or the logic is the same. So this is the exact code that we wrote previously. Now to make it into a function, what we're going to do is we're going to start off with the return type as int, the name of the function as sum of divisors, and this is going to take an integer number, int num. And after it has calculated all the proper divisors of num, then the result is getting stored in sum. It's getting accumulated in sum. Therefore, at the very end, the function returns the value of sum as that is the result that I want. Moreover, to get the sum of proper divisors of 220, we just need to call the function, right? Let's reduce the screen size a little bit. Okay. So how do we call the function? We write sum of divisors and we would pass 220. The function would return 284. Moreover, to get the sum of proper divisors of 284, we would call the sum of divisors function again, but by passing in 284, and it's going to return 220. So you see, we are reusing our code. There's no redundancy, there's no duplicacy, and we are writing less code. This is the reason why functions are important. Functions help us break a bigger problem into smaller problems. The subtasks that I mentioned in the first slide, so this is one subtask that we have completely solved. And this is an example of a dry code, which is an acronym for don't repeat yourself. Whenever you see that you are repeating yourself, you are writing code that is repetitive, where the logic is same, but you're just copying and pasting code, it's better to go for a function. Okay. Now let's move on to our second subtask, the subtask of figuring out whether two numbers are amicable pairs, two numbers form an amicable pair or not. And we are going to take the help of the function that we just wrote. So this is the algorithm for checking whether two numbers form an amicable pair or not. So in num1, we are storing the first number. In num2, we are storing the second number. Then we are checking whether the sum of divisors of the first number, proper divisors of the first number, is equal to the second number, and the sum of divisors of the second number is equal to the first number. Now, if this condition is true, that means num1 and num2 forms an amicable pair, else they don't form an amicable pair. And that's it. That's the simplest algorithm for figuring out whether two numbers form an amicable pair or not. But remember one thing, this algorithm is not a code. This is not a Java code. This is just an algorithm, a set of steps for you to follow. And in the next video, we are going to have a complete solution, a complete code for writing the code for amicable pair. But I want you guys to try out the code for yourself. Write the code for yourself following this algorithm. Moreover, you will require two functions in your program. The first function being sum of divisors. So int sum of divisors, that is going to take in a number in num. And the second function that you're going to require would be Boolean. Because there's no space, I'm writing it below, check amicable, and that's going to take in two numbers, int num1, comma int num2. And this particular function would contain the code following this algorithm. In your main function, what you're going to do is you're going to take two numbers as input. You're going to create an object of the class. call the check amicable method with the two numbers, and if this method returns true, then display that these two numbers form an amicable pair, else display they do not form an amicable pair. So try the code for yourself, and then if you cannot figure it out, then don't worry, you have the solution video there to help you. But still, I want you guys to try out the code for yourself first. So see you in the next one. Bye for now.